Okay, walk number 4. Keeping it real. Rewriting radical expressions. Warm up. Extract roots to rewrite each radical expression. Okay. Now, before we do that, we have to utilize these squared. So let's go ahead and write down our squared. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Dot, dot, dot. We keep going. But we're going to utilize the squares to simplify the square root. Okay. So that said, let's take a look at the square root of 48. So now, when we do 48 divided by 1, it doesn't do anything to help. So now let's take a look at the next square. 48 divided by 4. That's good, but let's see if we can go higher. So 48 divided by 9. Nope. 48 divided by 16. Yep, and we're down to 3, so it's as low as we can go. So we can rewrite the square root of 48 as 16 times 3. Okay, so then we can rewrite that as the square root of 16 times the square root of 3. Square root of 16 is 4, so that's 4 square roots of 3. All right, go and finish up number 1. Let's take a look at number 2. So we're going to do 27 divided by 1, doesn't help. 27 divided by 4, nope. 27 divided by 9, we're down to 3, it's as small as we can go, so that works. So we can rewrite this as the square root of 9 times 3, which that's the square root of 9 times the square root of 3, which is 3 square roots of 3. All right, go ahead and finish up number 2. All right, let's take a look at number 3. So 32 divided by 1 doesn't help. 32 divided by 4, that's good, but let's see if we can go higher. 32 divided by 9, nope. 32 divided by 16. Yep, we're down to 2, so that works. So we can rewrite this as the square root of 16 times 2, which is equal to square root of 16 times the square root of 2, which is equal to 4 square roots of 2. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. Getting started. The power of positivity. You know how to use the properties of powers to rewrite expressions. Number 1, simplify each expression. For each given expression, a not equal to 0. All right, so the best way to do these is to expand. A cubed is 1, 2, 3 times a. Well, that's 1, 2, 3, 4a, so that's a to the 4th. All right, b. So we have a cubed in the numerator, so that's 1, 2, 3, and then 7 a's in the denominator. 1, 2, 3, 4, 5, 6, 7. Now, anything divided by itself is 1, so this is 1, 1, 1. So you're left with 1 divided by 1, 2, 3, 4, a to the 4th. Okay, go and finish up b. All right, so we have a to the 4th in the numerator. Now, a to the negative 4th becomes positive a to the 4th in the denominator. So then we have 1, 2, 3, 4 a's in the numerator, 4 a's in the denominator. Anything divided by itself is 1, so 1, 1, 1, 1. So this equals 1. Okay, D. AB squared is AB squared times AB squared, which is equal to A times B times A times B. So we have 2A, so that's A squared and then we have 1, 2, 3, 4, so it's B to the 4th. Let's take a look at E. So a squared squared is a squared times a squared, which is equal to a times a times a times a, which is 1, 2, 3, 4a. So that's a to the fourth. Now, anything divided by itself is 1, so this is equal to 1. Here, we multiply the 1/2 times the here, and 1/2 times this. So this becomes a to the 8th to the 1/2 times b to the 4th 1/2, which equals a to the 8 divided by 2, b to the 4 divided by 2, which equals a to the 4th b squared. All right, let's take a look at h. So that's a squared, and then a to the negative 6 becomes positive in the denominator. So that's 2a's in the numerator, 6a's in the denominator. So anything divided by itself is 1. So 1, 1. So that's 1 divided by 1, 2, 3, a to the 4th. All right, go ahead and finish those up. 2. The expression a to the 6 divided by a to the 6 is equivalent to 1 because any number except 0 divided by itself is 1. A to the 6 divided by a to the 6 is equal to 1 because a to the 6 minus 6 equals a to the 0. And anything to the 0 power except 0 equals 1. Okay, mark out number 3. Let's take a look at the next page. Activity 4.1, extracting variables from radicals. Previously, you've rewritten radicals by extracting roots involving numbers. In this lesson, you will explore how to extract roots for expressions of the form n to the square root of x to the n. To determine how to extract a variable from a radical, let's consider several different values of n. 1. For each value of n, the expression n square root of x to the n, analyze the table and graph, identify the function family associated with the graph, and write the corresponding equation. Okay, go ahead and look over the table and graph. And then the function family of the graph is absolute value. And the equation of the graph is y equals absolute value of x. All right, let's take a look at the next page. All right, let's take a look at B. Go ahead and look over the table and graph. And then the function family of the graph is linear equation, and the equation of the graph is y equals x. All right, let's take a look at C. Go ahead and look over the table and graph. The function family of the graph is the absolute value equation. And the equation of the graph is y equals absolute value of x. All right, let's take a look at the next page. Let's go and look at D. Go ahead and look over the graph and table. And then the function family of the graph is linear equation, and the equation of the graph is y equals x. All right. E. Analyze the representations for each value of n. What do you notice? For each expression, the root is equal to the exponent. When the root and exponent are even numbers, the expression n square root of x to the n simplifies to an absolute value equation, y equals absolute value of x. When the root and expression are odd numbers, the expression n square root of x to the n simplifies to a linear equation, y equals x. All right, let's take a look at the next page. To extract variables from radical expression, n square root of x to the n can be written as n square root of x to the n equals absolute value of x when n is even, x when n is odd. Mark out 2. Method 1 and method 2 for extracting the root from square root of x to the 4th power for real values of x. Method 1, the square root of x to the 4th equals the absolute value of x squared. Method 2, square root of x to the 4th equals the square root of x squared times x squared, which equals x squared. Both methods are correct for extracting the root from square root of x to the 4th for real values of x. All right, go ahead and finish up your notes and have a wonderful Wildcat day.